Okay, so I've made this second video to go over two of the problems from the homework that I thought might be a little tricky. So the first is 2.4, number 61. So let's go ahead and look at 2.4, number 61. This is the Mount Everest problem. The highest mountain peak in the world is Mount Everest, located in the Himalayas. The height of this enormous mountain was determined in 1856 by surveyors using trigonometry long before it was first climbed in 1953. This difficult measurement had to be done from a great distance at an altitude of 14,545 feet on a different mountain. So here we have, I'm going to make this the mountain top of this different mountain, and this mountain has an altitude of 14,545 feet. From a different mountain, the straight line distance to the peak of Mount Everest, so now Mount Everest is over here, so the distance from this peak right here to this peak right here, this straight line distance, is not done in feet but in miles. Notice the unit change. 27.0134 miles. And that is with an angle of elevation. So here's the horizon line. Angle of elevation from this lower mountain to this upper mountain, this is not drawn to scale, is 5.82 degrees. So from here we're supposed to figure out the height of Mount Everest. So from this point to this point, this is also going to be the 14,545. So I have 14,545 right here. So the mystery is the distance from this point to this point. So I'm going to call that x. And then the entire height of Mount Everest is going to be the 14,545 plus x. That would be your height of Mount Everest. Now, this horizon line right here is going to be perpendicular to the altitude, because altitude is going straight up and down, horizon is going straight across this way, so we do have a right angle, and that's not an assumption, that's just based off the definitions of altitude and the horizon line. So we need to figure out what this side is here, and we can figure out what that side is, what x is in miles, and then convert it to feet. That would probably be the simplest thing to do. So this is going to be a sine problem. The sine of 5.82 degrees is equal to opposite over hypotenuse, 27.0134. And this is in miles, remember. So to get x, we're going to just multiply sine of 5.82 times 27.0134. So then we have the sine of 5.82 times 27.0134, and that is going to be approximately 2.73925 miles. Okay, that's still quite a height. We do not want to add this number onto this number because this is in miles and this is in feet. All right, so how many feet are in a mile? And the answer to that question is there are 5,280 feet in 1 mile. So we're going to do a unit conversion here. So I'm going to take this number that's in the calculator and just multiply it by 5,280. And that is going to be approximately 14,463. And I'll go ahead and round to a whole number here because I have a whole number over here. So the height is then going to be this x value, 14,463, and add to that your 14,545. and you get 29,008 feet. Now, in the book, they write it as 29,000 feet, which would be more appropriate given the significant digits. You see over here that I only have 3 significant digits for my angle. Since my angle only has 3 significant digits, I'm only allowed to go out 3 significant digits here. And if I went all the way to 8, that would actually be 5 significant digits. So I have to round at the point where that first 0 is, which would round to 0. And that's why the book is going to give you this. It's because of significant digits. Significant digits. All right, now from there it says in the actual measurement, Mount Everest was over 100 miles away, and the curvature of the Earth had to be taken into account. Would the curvature of the Earth make the peak appear taller or shorter? If the Earth is curving, then the mountain would be appearing to be shorter, and they would have to take the curvature of the Earth into account in order to do this problem. So we're not doing spherical trigonometry or spherical geometry. We're doing, the assumption of everything we're doing is that we're in a plane. And for short distances on the Earth, of course, that's completely a fine assumption. But if you're dealing with larger distances on the Earth, then you do have to take into account curvature of the Earth. But that's way beyond the course here. So we're going to just focus on flat planes in general. Okay, so the next problem I wanted to do one more problem to help you out with the homework, and that's 2.5, number 39. Okay, so in 2.5, number 39, we are dealing with the height of a plane above the Earth, and we have a diagram that shows our Earth, not drawn to scale. We have from the center of the Earth to a point on the on the rim here, we have C and B. This would be a tangent to the Earth, and so it's perpendicular, and that's where we get the right angle from. Any tangent is perpendicular to a radius of a circle at the point of tangency. So point A is the airplane. So find the minimum height, h, and height is going to go from this dot here on the Earth. This would represent the height of the airplane from here to here. Find the minimum height above the surface of the Earth so that the pilot at point A in the figure can see an object on the horizon at C 125 miles away. And then we are assuming that the radius of the Earth is 4.00 times 10 to the third miles. In both cases, we have 3 significant digits. Now, this side is also going to be 4.00 times 10 to the third miles because both of these are radii of the same circle, and radii of the same circle are congruent. So you see how much of geometry shows up again and again throughout trigonometry. So having a good foundation in geometry is really, really helpful in this course. So for this, we're just going to use the Pythagorean theorem. Let's call this side right here side C. So then a squared plus b squared is equal to c squared, right? So c squared is equal to a squared. There's your 4.00 times 10 to the third plus b squared, 125 miles squared, is equal to c squared. So let's figure out what that is real quick. 4 times 10 to the third is, of course, just 4,000. That's kind of a fancy way of writing 4,000. You might say, why did they go to all the trouble of writing 4.00 times 10 to the third and not just write 4,000? Because if you write it this way, you can see that you have 3 significant digits. But if you just write the number 4,000, it looks like 1 significant digit, and that's the difference. So we have 4,000 squared plus 125 squared. Then we take the square root of that, and we find that C is equal to 4001.95 miles. So if you subtract the 4.00, that leaves you with H as 1.95. So that's 1.95 miles above the Earth. Make sure that you have a reasonable answer. You don't want to end up with a airplane that is 1,000 miles above the Earth. So this is a reasonable answer, that we would have the height of the airplane be 1.95 miles above the Earth. Okay, all of the other problems that you may have had to do in the homework, you either had solutions in the back, or I did the even problem that accompanied the odd problem, or I thought that the problem was straightforward enough in its explanations from the book. Hopefully you were able to troubleshoot through those and figure them out. If you still need help retrospectively, then we can perhaps meet together, or I can post a video that if multiple students are having the same difficulty. But I would also recommend, remember that in the Start Here module, I have that Help button section, and there is tutoring through Matsu College for math and tutoring through SLED. So both of those are really good sources to get some help. But I can also meet by appointment sometime in the Math Homework Lounge. That would be a possibility. I just have to arrange that with my family's schedule. But I do want to be available if there's a particular problem that's really difficult and multiple students in the class are struggling with it. It may be even just most efficient that I record a video of how to do that problem at some point and then post it. Tuesdays and Thursday mornings are my recording video days for this course. So I come to the college on that days in order to do my recordings. So that would be another option. All right, so I look forward to seeing you again. Well, you will see me, but I do look forward to engaging with you again shortly.